Okay, this is my Milestone 1 video. So I'll start with my model converter. So in the model converter class, I output everything to this test folder. So this is where I store the existing FBX models. And so the way I dealt with the multiple textures per model is I basically just put them in a text file. So the Warbear, for example, has the two TGA files to be read in. So I have the Warbear TGA and the Polar Bear TGA. And I'll show you how I spit those out in the converter. And so these are the corresponding TGAs down here and the models up above. So to get the converter, we have to build the project first. And I could talk about how I went about doing this. So inside this converter project, go into main, and I can talk through how I figured this out. So I basically think starting around here. So what I did is I took our exact model header that we used for the Azul objects from before. And so I gave it the number of verts, the buffer offset, the number of tries, and then the try list buffer offset. And I also included a sphere struct for the bounding sphere that we were using for the Ritter sphere, which is basically just the center point in the radius. And so in doing that, so essentially what I do is I take the existing FBX and I write it out as a bin file. And then I write each of the verts into that bin file, and then I set the offset, and then I calculate the bounding sphere based off of those points. And then for the try list, I'll right below the vert list, I'll write the try list out. And I guess I should have mentioned in the beginning, I write an empty model file header that I talked about previously. So I will write an empty one first and then fill it as I go. So I will basically set all of the offsets and the total number of verts or tries. So then at the very end, after I add all of the data, I will simply jump with the file system and I'll seek back to the beginning and write out that header. So all the final information gets passed into that, and then I'll close it. So then what I do from there is I will take the vodka converter and I will read in all the binaries for this specific file, which of course is just the one binary for the model and then the TGA models as well. So I'll take in the binary and output it as a BLO file. I then take the TGAs found in the textures file and we'll write those out as BLOs as well with a TGA underscore TGA, so I know that that's from that specific model. And so I'll do that in a loop where it'll loop through as many times and basically split it based on the new line character. And then in the look it up, it'll be whatever BLO files were created during this specific model's build. We'll put those into its own SPU file and then delete all the temporaries. So if I go ahead and build this, I have everything building to that original test folder that I showed in the beginning containing the models and the TGAs. So if I go back into that, I run this all from a batch file. And so you can see that the look it up exes and the lib files and the model converter all gets outputted into this main folder. So then from here what I'll do is I just run the batch file, which just contains it deletes any existing SPU files just so we're not dealing with overwriting or rewriting. It just clears them out and then rebuilds them from scratch. And so it deals with one model at a time. So I call the model converter just on the space frigate spaceship model, and then it'll delete the temporaries for that. And then I call for Astro Boy and the Buggy and the Warbear, etc. So now, because we have built this, you can see all I have now is the FBX, textures list, and the textures themselves. So if I just start the script, it'll start to run through and generate these SPU files, which you'll see spit out in this folder over here. And so I did hide a couple of the prints just in terms of speed, just to make it go a little quicker, because it was running pretty slowly every time I'd run it because it was still printing all of the different versions of the lists. So it's writing out the different chunks. So once we have all of these, what I did was I took all of these SPU files and I just copy that, and then I put this into my engine. So in my engine, I'll just overwrite the ones that I had in here previously. So you can see all of the model files were contained in these SPU files. So I'm just going to go ahead and overwrite them. So now if I open up my engine project, I basically left the condition to where I can read in from a single model, as we did for the Azul, for basically the primitive shapes, for the cube and the pyramid and triangle and diamond is what I had previously. But then I also added an overloaded model constructor where it'll take in a file name and a model name, and that will read from the SPU files themselves. So if I go into the game class, I could show you how I'd go about that. So right now I have the models loading in. So basically I call out that SPU file that was created from the converter, and then because I gave the name space forget in the converter, that's the specific model I'll be searching for. And then I do that for the textures as well. That's why I added that underscore TGA, just so it'd make it easier and make it consistent. So I could just, inside the this add method and inside the model, basically we'll just use the eat function that we created to eat the chunk and then give us the desired object or texture. So then if I go ahead and run my engine, I have the models being added, and the nice thing was I had a camera manager already set up to handle multiple cameras, so I really just needed to create the frustum and the calling and the bounding sphere. So I go ahead, I pre-calculated the bounding spheres in the converter, so when I retrieve those in this file, I basically just need to update it if the scale or rotation and position based on where I move these models around. So now we have a succeeded build, so I will run it. I'll show you what I'm talking about. So I just lined up all the models to make it easy to see. And I did have one test sphere that goes front and back, and I just made it go up and down, left and right, just to make sure that once it goes past that plane, it will turn red. So I basically have all of the models in here side by side, and they're all instancing the exact same model object. So I actually only added these models once. So the Astro Boy, there's only one Astro Boy model, there's only one War Bear, there's only one ship, even though there's two instances of it, so you only load the model up once, and then you can reuse it. And so if I go ahead, I could turn on the bounding spheres for each of these. And so you'll see the green ones are, if they're within the other camera's frustum, they're green. So I could start to shift that field of view, and as they leave the frustum, they turn red. And so we can also test this by jumping into this camera, and we can change the field of view, but we can also start to move it sideways. So if I now switch back to the overhead camera, you'll see that these ships are, or the farthest ship on the right is red. So if I keep going, both of them should be red. So it works properly. So another feature I added to this was I was able to select the objects with sort of a wireframe mesh. So if I turn off bounding, I target the current camera that I'm on, the active camera, and so it'll run through each of these objects. And so obviously that sphere that's where its location is. I'm not actually updating it every time, but for these specific models themselves, you'll see that the target camera is this specific model, so I can rotate around and zoom in just that one specific model. And so what I did was I have a semi-transparent wireframe mesh over the selected model, which will go to each different one of these models, and it scales properly with it. So I have the cameras look at just adjust based on which active object is currently selected. And so the Warbear I also implemented where I can swap the different textures, where I had the polar bear and the Warbear textures. I need to figure out a better way to do this for all of the models, because currently I have it hard-coded, so right now if I switch everything, it'll basically turn everything into a Warbear or a polar bear. So I can keep selecting through here and here. And so yeah, I can handle multiple cameras. I'm trying to think of anything else I needed to add. I have yet to create the default texture, so if a texture is not found, it defaults to the null. I still need to implement that. And then I also have 2 different camera styles, which is pretty much the same as last quarter, where this one is more of it'll orbit around the specific model, and the other one is more of a first-person shooter style, but I don't believe I have one of those cameras created in this demo. But yeah, so that is my Milestone 1 demo.